Hello, this is Eduardo Suarez. Today we're going to look at explicit messaging and how we can read an active alarms on the robot controller and show it on a panel view HMI. The robot controller is an explicit messaging server and supports connected and unconnected explicit messaging. There are a variety of assembly objects that can be used for accessing the input and outputs in the robot controller. And in particular today, we're going to look at the active alarm assembly object. We're going to start by getting the FANUC reference manual for this application. We're going to go to the web page for the fanucamerica.com. We need to log in. We're going to log in to my portal. From here, we can log in. And once we have logged in, we can go to eDocs. And what we're going to do, we're going to look for the manual that is going to be the one that I already know the part number. And the one we're going to download is the one that says Ethernet IP setup and operations for the controller version 9.4. You're going to find out on this manual there is a section 7 that is dedicated to the explicit messaging. Now we're going to go to RoboGuide. We're going to create a work cell, and there are only a few things that we need to configure on the robot side. We're going to go to the robot controller. We're going to go to properties. And you're going to see here that I've already installed the Ethernet IP scanner package. In reality, the one that you need is the Ethernet IP adapter package, but the scanner includes the adapter. We're going to configure the Ethernet connection. We're going to open the pitch pendant. We're going to go to menu, setup, and host communication. On the setup screen for the host communication, we're going to go to TCP/IP. We're going to go to details, and we're going to configure the IP address and the subnet mask for the robot. And in the host name, we're going to add the PLC, and we're going to add the IP address for the PLC. Once you have the connection working on the real controller, you can ping it and find out if the communication is working. One more thing that you need to notice is that I configure the PLC on the slot 1 for the communication. We're going to need this one when we do the connection for the input and outputs. So now we're going to configure the inputs and the outputs. We're going to go to menu, I/O, and Ethernet IP. You're going to see here that I have the PLC on slot 1 and the connection is disabled. So we're going to go to configuration, and we're going to assign the number of input and outputs. In my case, you're going to see here that the size is in words, and I've selected 16 words for input and 16 words for output. That means that we're going to have 256 input and 256 outputs. When this is done, you need to go back and enable the connection, and in order to get this one active, you need to cycle power the controller. We're going to go to menu, I/O, and we're going to go to digital. We're going to start with the digital inputs, and we're going to go to configuration. On the configuration for the digital inputs, we have 256 input starting from 1 to 256. You see here that is starting from 1. And we're going to assign this one to the Ethernet connection that is rack 89 on slot number 1 that corresponds to the PLC. Once you're doing this one for the first time, this is going to show pending. That means that if you want to get this one active, you need to cycle power. So you're gonna do this one once you have configured everything. Now we're gonna go to the digital outputs, and for the digital outputs we're gonna do exactly the same. We're gonna assign the Ethernet connection on rack 89 to the slot 1, starting from 1 to 256. And we're gonna do the same for the UOPs. We're gonna go to type, UOP. We're gonna go to input, configuration, and we're going to configure the Ethernet connection to the slot 1 started on 1. And for the outputs, we do exactly the same. Ethernet connection to slot 1 starting from 1. And you see here that shows pending. That means that we need to cycle power the controller to get this connection active. And that's all that we need to do from the robot controller side. You're going to notice one more thing, that I'm overlapping the UOP inputs and UOP outputs with the digital input and digital outputs for the robot controller. Now we need to create a PLC program. I'm using Studio 5000, and I have created a program for the compact logic controller AL320 ERM. You go here to properties. You're going to see the controller that I'm using, but this one can be done for the compact logic or the control logic. Is going to be exactly the same. This particular controller has two ports on the Ethernet adapter, port A1 and port A2. So in the port A1, we're going to configure the connection to the robot. I have the connection established already here. But if you want to do this one for the first time, you select the Ethernet adapter, you select new module, and here on the filter, we're going to select FANUC, and the one that we're going to use is going to be the FANUC robot Ethernet IP robot. And then you just press create, and you just need to fill up all the information that we have in here. So I'm going to close this one, and I'm just going to open the connection that I've already created. I give it a name. That's going to be robot 1. I put in here the IP address for the robot, and on the module definition we can go to change, and we're going to go to connection, and we're going to select the size for the input and outputs. Notice that on the robot controller side the size is in words, on the PLC side is on bytes. That means that we need to select 32 input bytes for input and output in order to have the 256 bits. And with this, we have the connection to the robot controller. We're going to go to the controller tags, and you're going to see here that this is going to be our tags for the robot connection. You're going to notice one thing in here, that the robot inputs refers to the inputs on the PLC. That's going to be the outputs in the robot controller. The same, this is going to be the outputs from the PLC side. That means that's going to be it's going to represent the robot inputs. On my case, I'm creating a new tag that is going to be robot, and what I'm using for the data type is going to be a UDT that I call it robot FANOC, and this UDT includes two more UDTs that's going to be PLC inputs and PLC outputs. And on the PLC input, I'm going to have the digital outputs from the robot controller. You're going to see that because I overlapped the UOPs with the digital outputs, and the same for the digital inputs. We're going to have in here the EOPs starting from 1 to 20, and then we're going to have the digital output started from 21. And it's going to be exactly the same for the digital inputs. So now, if we go to the robot outputs, that's going to be the digital inputs on the robot, and that looks confusing if you're not used to that. Again, we are overlapping the UOPs with the digital inputs, so we're going to start the digital inputs from number 19. And we're going to go to 56, and then we're going to have the UOP starting from 1 to 18 over here. And that's the way that I configure the UDT for the robot FANOC that we're going to be using on the tag robot. So we can close this one for now. I have a few more tags that I'm going to explain later how they work. So now I have created a routine. We're going to go to the main program, and I'm going to open this one I call messaging alarms. Over here, you're going to see that the first thing I'm doing on rank number 1, I'm mapping the inputs from the robot connection on the Ethernet connection with the robot to my tag that I created that is robot.inputs, and I'm doing exactly the same for mapping the outputs for the Ethernet connection to my tag that I call robot.outputs. Over here on this run, what I'm doing is creating a timer. That timer is going to be 1 second based, and what it is doing is going to trigger the messaging instruction that we're going to be using here. That's going to be triggered once every second, only when we have an alarm active. And this alarm active comes from the UOP. That's going to be output number 6 on the robot controller. That means that we have a fault present. So now everything that we need to do is going to be just creating a messaging connection. And if you click in here on the configuration dialog, you can open up this message. And what we have in here is all that we need to do for the connection to the robot and getting the information for the active alarm. We're going to select the message type. It's going to be CIP generic, and all this information is on section 7 for the manual that we have downloaded at the beginning of the video. The service type that we need to select is going to be get attribute single, and once you select this get attribute single, you're going to have the service code that is E. That's why this is gray out. You cannot change this value. The class is going to be a 0 on a hexadecimal number. 8 means that we're going to get the active alarm object for the message. instance number 1 means that we're gonna get the most recent active alarm. And just to give you an example, if you select, for example, instance number 2, you're gonna get the second most recent active alarm, and so on. Attribute number 8 means that we're gonna get the alarm message, and the alarm message is configured as 88 character string. You're gonna see on the manual there are a lot of different attributes that you can select. For example, the reason for the alarm is gonna be one of the attributes that you can select, or you can get the start time. Now on the destination element, we're gonna select the robot alarm string 88, and over here we're gonna get the string for the active alarm and information that we have coming from the robot controller. By default, this is gonna be a string of 88 characters. And on the communication, the path, we're gonna select browse, and we're gonna select the connection that we have established on the Ethernet adapter for the robot controller that I call robot1. And that's all that we need to do. Once you have this one configured and downloaded to the PLC, and you have you're gonna get information on the tag, and you can see here that I already got the information. If we go to if we monitor the tag for the robot alarm, you're gonna see here that we get the message server 3 dead man switch released. And once we don't have that alarm anymore, what we wanna do, we wanna use an empty string that is gonna delete information that we have on the robot alarm. I wanna be able to show you how this one works, because I need PLC for that, but I'm gonna show you here. I just took a picture of the alarm that we have on the teach pendant, and this is exactly what you're gonna get on the messaging on the tag that we have created over here. So now what we need to do, we need to create a new routine that I'm gonna call it alarms. And once we have the alarm trigger from the robot controller, we're gonna set a bit that is gonna call alarms bit number 0. That is the alarm that we're gonna use on the panel view HMI. So now we're gonna go to the panel view HMI. The first thing that we need to do is we need to create a connection to the PLC. So we're gonna go to factory link, factory top link. We're gonna create a connection. I call it PLC, and that is gonna be the connection to the PLC on the IP address 192.168.1.10. Once we have that connection working, now we can go to the alarm setup, and on the alarm setup I have configured the tag for the alarms, and this tag we're going to use the trigger type is going to be by bit, and I put a label that's going to be alarms. And now when we go to messages, you're going to see that the trigger value number 1, that's going to be for the alarms on bit 0. It's going to show the message alarm number 1 robot faulted, and we're going to get the tag from the PLC with the alarm message. If you don't know how to configure this one, what we can do, we can select the tag over here, and I'm going to open the screen for the alarms, and over here we're going to select a new object. We're going to go to string, and we're going to select string input enable. We're going to create a new object. We're going to go to label, insert variable. We're going to select string. We're going to select the tag. That's going to be the robot alarm string. That's a string that we're going to show on the message for the alarm, and we're going to select OK. And this is going to give us the formatting for the string. So now we can just select this formatting. We don't need this one anymore. We can delete it. We go back to the alarms and we paste this information over here. So now that we have the alarm configured, we just go to the alarm screen. We create an alarm message and we just show the message over here. That's all that we need to do. As you can see, the procedure is very simple. Just we need to create a message instruction on the PLC side that's going to be triggered when we have the alarm, and we just need to configure in here the information for the active alarm according to what we get from the section 7 on the reference manual for the Ethernet IP setup and operation.